In this video, I'm going to model how to construct the orthocenter. The orthocenter of a triangle is constructed using 3 altitudes. To make an altitude, find a vertex and try and construct 2 intersecting locations with an arc or on the other side, and then use those intersections to find a point that is equidistant from them on the other side of the base. So in this case, here's my altitude, and this is 90 degrees on that side. Just to make sure we know what we mean by altitude, if you were to take like an index card and you were to slide it along one of those sides, using that as your 90-degree angle, you can slide this along this side, and this basically meets up with the vertex. We're looking for a place where there's a 90-degree angle along the base and it matches up with the vertex of the triangle. So again, I can slide this along, slide this along, slide this along. I'm not quite at the vertex. I'm at the vertex, and that's my altitude. The distance from the base to the vertex on the opposite side of the triangle. And we need to do this 3 times. The technique here is how we do it with the construction. The index card is just like a shorthand to confirm your work or justify that it's working out all right. Let's make 2 more of these. So I've got my intersecting arcs. And now I want to connect that point, the vertex, on the opposite side. And I have the height along this side of the triangle. Do that one more time. If everything's working out correctly, this should be my orthocenter. Hopefully it is. My vertex. Got 2 intersections, looks like here and here. So I'm going to use those points. And I've got my last altitude of the triangle. So I have 3 altitudes in there. And voila, orthocenter. One thing you should note is the orthocenter, in this case, I did an acute triangle, and only the acute triangle has an orthocenter inside. If you had an obtuse triangle, the orthocenter would be located outside of the obtuse angle. And if you had a right triangle, the orthocenter would be located on the right angle. The equilateral triangle is the only triangle that has both the orthocenter, the circumcenter, the incenter, and the centroid all located in the same exact location, which would be inside the triangle. If you look here on this triangle, it should be pretty obvious the distance between this point, the orthocenter, and the vertex is not equal in any of those 3 directions, and the distance between the orthocenter and each side is also not equal. If this had been an equilateral triangle, then all of those lengths would have been equal, but that's the only type of triangle that has anything special going on that we need to know for this unit. I hope this is helpful.